Hey guys, today we are going to talk about the intermediate value theorem. It is an extension from what we learned on continuity, the concept of continuity, and the one-sided limits lesson that we had yesterday. And it's just one of the topics that we need to finish up. So, what is the intermediate value theorem? It's really a theorem, it's referred to as an existence theorem. If these conditions are met, it proves the existence of this. Okay, so it's an existence theorem. It can be used to locate zeros, and what I mean by zeros, that was a little bit too bold. Let's change that up. What I mean by zeros are graphically, you can think about it as x-intercepts, or you could think about it as the x value that makes the function zero. So it can be used to locate zeros of a function that is continuous, very key word for this, on some interval that we're given. So here's what the theorem states. And once again, we got to get comfortable with this math notation and the language that's used and try to visualize what they are saying in the statement. So if f is continuous, no holes, no jumps, no gaps, no vertical asymptotes. It's a continuous smooth curve on a closed interval a to b. So the function is continuous on some interval a to b. Okay? So try to think about that picture, trying to draw it out. And k is any number between f of a and f of b. Okay, f of a is there. The y coordinate, f of b is there. K is between. Okay, k. K is between. Then there is at least one number, call it c, in a to b where f of c is k. All right, so c. And then k is now the same thing as f of c. Yeah, okay, that makes sense. So we've got a continuous curve. You've got these values in between. It's just proving that in between a to b, there's some x coordinate that has a y coordinate that's in between f of a and f of b. One way of thinking about it is this. Let's say, for example, you're driving your car. And as you're driving your car, you are going at one moment in time 25 miles per hour. Well, then a few seconds later, you are traveling at 45 miles per hour. Well, doesn't that mean at some point in between that time frame, that window of time we're talking about, didn't you at some point have to go 30 miles per hour at some point? Yeah, it does. You have to pass through it. So that's what's stating here. If it's a continuous amount of time that's taking place and a continuous velocity, yeah, it has to go through 30. At one point when you guys were growing up, you were only 2 feet tall. Hey, maybe now you're 6 foot. At some point, weren't you exactly 4 feet tall? Continuous type of concept. The values are in between. That's exactly what we're doing here. So how do we use this in one application mathematically? Now, there's going to be a whole lot more we do with this later on in calculus, but just it's a big idea, a big concept. It comes up in a lot of the AP free response questions as well as a prove the existence of this taking place. One thing I do want to touch on though is the idea of continuity. If the function is not continuous on your interval, you cannot use this theorem. Here's why. If we can say this proves for x-intercepts, let's say we have an interval here, and this is what our function looks like. Okay, let's say we've got an interval a to b. If we're going to think about proving the existence that there is an x-intercept, well, it has to be continuous to cross through. But at A, we've got a value here. At B, we've got a value here. But notice how it doesn't cross through ever, and there is no x-intercept, basically proving that it does not exist to have an x-intercept. So it has to be continuous. Okay, it has to be continuous to apply this idea that it goes from 25 miles per hour to 30 to 40 to 45 to 50. It's a continuous value. Well, this is not continuous. There's a vertical asymptote in between. So even though it goes from positive value to a negative number, it does not prove that it passes through 0, which it would if it were continuous. So here's what we have. Here's our example. Just one example for the day. If the function is continuous on a to b, and f of a and f of b differ in signs, positive, negative. If they differ in signs, that proves there is a 0 on the interval. That proves there is an x-intercept on the interval. So here's the question. Use the intermediate value theorem to show that this function right here has a 0, an x-intercept, on the interval 0 to 1. So we're not trying to find it. Like, we don't want to even know what the x-intercept is. That does not matter for this question. The only thing that matters is if we could determine that there is one, that one exists. So what we do is we find f of 0. Plug it in, see what you get. 0, 0, negative 1. Then we also find f of 1. F of a, f of b. Interval here, find f of 1. Plug it in, 1, 2, minus 1. So we are at, 1 plus 2, 3 minus 1. We are at 2. So think about this graphically for a second. 0's down at negative 1. 1 is up at 2. Doesn't that prove at some point it passes through and has an x-intercept? Yes, right? So because these differ in signs, right? These two differ in signs. What does it do? It proves that there is a 0. It proves a 0 exists. Remember how I said this is called an existence theorem? It doesn't matter what it is right now. We're just saying that one does exist and it will take place. Okay? Last thing though, the question is it continuous? Because it's got to be continuous function on this interval 0 to 1 in order for it to exist. And this is a cubic polynomial. Of course it's continuous. It's a cubic, right? So it's going to take place. There's nothing you have to really show to prove that. It's just our understanding of functions. That is it for the day. At this point, you guys can start working on the assignment from 1.4. It's the scanned in version of the textbook, and you can complete that practice set.